It is really an honor to be here today to tell you about some of the things I'm really passionate about. And these days, I can really picture a world not too far off in the future where it is as easy to program a robot to do your shopping or to take a driverless car for a spin as it is to use a smart. We really believe that robotics has a huge potential to improve our quality of life at work or at home, and at the same time power the economy, advance scientific discovery, and generally make the world a better place. Yet, the purpose of robotics is not to, this is not working. The purpose of robotics is not to replace, can you advance? The purpose of robotics is not to replace humans by mechanizing tasks, but it is to figure out how machines can assist humans with their enhanced capabilities so that together the human-machine ensemble is more effective. So for instance, you can imagine taking a driverless car for a spin on your commute. This will buy you time. This will allow you to work, or to do your email, or to read, or to catch up on podcasts, or your favorite friends and family. Now imagine if these self-driving cars, which we're all talking about these days, imagine if these cars begin to learn. Learn how to drive safely, learn how to not be responsible for collision, learn what we like when we drive, learn how to watch over our shoulders on a particularly treacherous stretch of the highway, and make sure we don't make a mistake, and maybe even make our time in the car fun. And what if the cars could begin to talk with our other devices? Maybe the car can talk to our refrigerator to figure out that we're out of cat food for Feifei's cat, very important, and figure out a place where you could detour to stop and buy that food. So these are just a sample of possibilities that we have when we put robots, cars, and computation together, and machine learning together. But what I really imagine is a future where everyone can have a robot, a future where we have many people working with many robots for many tasks, and you do not even have to be an expert to do that. This is the world of pervasive robotics. In this world, shopping might look like this, and by the way, there are 19 robots in this picture. Some of the robots deliver packages, so maybe you can send your robot to do the shopping for you. Other robots clean or help carry packages or stock shelves. And if you want to do your own shopping, perhaps your self-driving robot cart can take you directly to where the items you're interested in are. Now, pervasive robotics is a huge challenge. But this challenge is not that much different from the pervasive computing challenge, which was formulating in the 1990s, a mere 20 years away. And just look where we are today. Computation and information are already democratized, and in my opinion, the next step is democratizing physical tasks. Now, there are huge gaps between where we are today, and these are some of our super amazing robots. Yet these robots are not capable yet to deliver on this dream of pervasive robots. These robots cannot figure things out very well, they cannot communicate with people and with each other very well, they cannot perceive very well, as we saw in the previous talk. And it takes too much time to make robots. You really have to be an expert and spend many years of time to create new robots. So a question I'm interested in is whether we can speed up the fabrication of custom robots towards this big dream of pervasive robots. So let's take a regular user, not an expert in the field. Let's call her Alice. And let's say we want her to begin to automate a lot of tasks in her home. Maybe she wants a playmate for her cat while she's at work. So Alice heads to a new type of store called 24-hour robot manufacturing, where equipped with an intuitive interface and with design support, she can explore the design space, figure out the design that fits with her needs. And when she's done with that process, 24-hour manufacturing will print the design, augment their database with a new system, and the cat will have a playmate. The robot will come equipped with body, computation, and programming. So how crazy is this idea? Can I type in my email buffer, I want a robot to play chess with me, and then say make, and in response to that, have a program that figures out what are the behaviors for my robot, then synthesize mechanical components, computational components, and the programming needed for the robot, and then produce a working system. And so here's the robot that plays chess with you. Now, this robot was fabricated using a program we call the robot compiler, where the idea is that you give a high-level specification, the robot synthesizes a mechanical structure that meets the specification, computational infrastructure, and programming so that everyday users can use these machines. Now, a big part of what it takes to make those robots is folding, because we make them using print and fold techniques. And so we ask, can we automate the folding process, since that takes the largest amount of time? And we answer yes, by using heating, by baking your own robots. And here's the secret sauce. You can think of the body of the robot as a sandwich structure where you have a top and bottom layer that are structural, and the middle layer shrinks when exposed to heat. If you have kids, it's shrinky-dink. By cutting gaps in the top and bottom structure layers, you can control the folding angles when the system is exposed to heat. So here's how it works. You give your system a picture, let's say it's the Stanford bunny. The system creates a mesh, unfolds the mesh, records the angles, and then figures out automatically how to fabricate the body that when exposed to heat will fold up in exactly the desired system. So here's the robot that was done using this pipeline, using this compiler. This robot can run at 4 body lengths a second. It can avoid obstacles. It can climb on things. It can carry objects. And it can do a lot of marvelous things. So what can we do with this for the greater good? Well, and the robot can also recycle itself. So what can we do for the greater good with this technology? So imagine maybe making microsurgeons that you could ingest to enable surgery by ingestion instead of incision. So you take your robot, you package it in a capsule. The capsule is frozen in ice. When the robot gets to your stomach, the ice melts, the robot unfolds, and then the robot becomes controllable. You can direct the robot to wherever you want it to go. So any minute now, the robot is going to start moving. Okay, in a controlled way. And with this system, you can then imagine ingesting these microsurgeons and having them do interesting tasks that currently require incisions. In this case, the robot will remove a button battery lodged in the stomach coating. You can also imagine the robots delivering medicine or patching wounds. So what I'm excited about, really, is the current state of the world, where we can imagine the impact of pervasive robotics. And just like the App Store has democratized access to computation, I believe that by democratizing physical tasks, we can have an equally profound impact on the world. And if we can do this, we will make a lot of robots. And what's not to love? Thank you.